Yes, everyone, please join fast. Can you hear me, please? Hello, can you hear me? Okay. Please tell the other students to join fast. It's only 11, I guess. Can you see the board also very well? Yes, tell the students to join fast, please. And use your full screen mode. On the right hand side, there will be an option for full screen. To go for a full screen mode. Come on, please join fast, everyone. I can see only 18 has joined so far. What about the rest of the students? I request you all that please no other messages, please. Only related to the lecture. Please, you can message. I request Gogari to please behave yourself as far as your comments are concerned. Please let all the students join fast. Come on, drop a message. It's only 19 total out of 37. Hello. भेजो उसको.
मला तर नाही वाटत तेवढं बोलायची गरजच नाही सर. अगोदर पाठवलं आहे ते पाठवायचं आहे. प्रॉब्लेम तर पूर्ण दुनियाला झाला सध्याला. तेच म्हणतो प्रॉब्लेम तर तुम्ही जसं बोलताय पूर्ण दुनियाच प्रॉब्लेम आहे. आम्ही पण कुठे कंटिन्यू कामावरती आहे कसं बोलून मग तो आपण माझा इशू नेहमी पण बोलू शकता असं तुम्ही ज्या हिशोब बोललो तर मग ते सांगतो ना तुम्ही आम्ही पण सत्य तुम्ही येणार जे पण असं मी सांगतो मी तुम्हाला मी माझ्या कंपनी करता करतो ना मग तुम्ही बोलता मी कबूतर पाठवते पाठव मी तुम्हाला काय बोललो काय सर मग तुम्हाला मी बोललो होतो मला व्हॉट्सअप करा करू तुम्ही व्हॉट्सअप नाही केलं मला SMS नाही सर व्हॉट्सअप बोललो मी तुम्हाला नंबरवर तुम्ही फोन केला ना प्रत्येक जण एवढं सांगायचं तुम्हाला तुम्हाला 2 ते 3 दिवसाला तुम्ही फोन केला तर मला तुम्ही म्हणाले की मला स्टॅटिक ऍपिड ठीक आहे स्टॅटिक ऍपिड पाहिजे ना तुम्हाला ते राउटरचं पेज ओपन करा मी पुढे मेल टाकतो फोन जाईल राउटरच्या पेजमध्ये स्टॅटिक ऍपिड सर्व्हिस निघाल राउटरचं पेज ओपन करणार पाणी काढी ना तुम्ही लाईव्हच नका तुम्ही फोन जवळ नाही त्याला माणूस राउटर आहे ना साइडवर जादू आहे उभा राहण्याने झालं ते आलं तर जाईल त्याला काही काही नव्हते पण करतो तर होतात ना अच्छा तशी काही नाही जायचे याला काही काही हाँ ओके सर ना ना बरं आहे What has happened? Why the students are not joining? Tell me please, what has happened? I'm still waiting for it's already 10 minutes gone. Hello, can you hear me? Okay, come on, we can start then. Last time, if you remember, we were talking about the anomalous behavior of oxygen as well as fluorine. Okay, so after that, now we can start off with the next point, and that is chemical properties. So we begin with the chemical properties. Okay, it is what? Chemical properties. Now, when we start with chemical properties, the very first property that we are going to talk about is oxidation state. Oxidation states. दिख रहा है आप लोग को क्लियरली? क्या आप सभी को ये क्लियरली दिख रहा है? Please reply. Can you see this very clearly? Okay. Abhi oxidation states, we are going to start with group number is 16. Okay. And in group number 16, we are going to consider the electronic configuration as NH2 and NP4. ये configuration है, ठीक है? NH2 as well as NP4. अब इनके पास the general oxidation state की अगर बात की जाए, the general OS, और वो क्या होगा? It has got 6 electrons in the outermost shell. So one possibility is it is going to gain 2 electrons and achieve the octet. 6 इलेक्ट्रॉन उसके पास है, 2 इलेक्ट्रॉन गेन करेंगे वो, तो इट बिकम्स व्हाट? -2. ठीक है? नेक्स्ट इज वो 4 इलेक्ट्रॉन लूज भी कर सकते हैं. यू कैन लूज दिस 4 इलेक्ट्रॉन्स, तो 4 जाएगा +4. Another possibility is it can lose this 2 also, so that means it gives you +6. लेकिन दोस्तों ये जनरल ऑक्सीडेशन स्टेट है. ओके, इट इज व्हाट? जनरल. -2 +4 +6. इसके अलावा भी ये एलिमेंट्स और ऑक्सीडेशन स्टेट दिखा सकते हैं डिपेंडिंग अपॉन द नेचर ऑफ द एलिमेंट विथ विच इट इज कंबाइनिंग. उनके ऑक्सीडेशन स्टेट इज अ चार्ज and an element will show a charge only when it is going to combine with another element. So first condition is it depends upon the nature of the element with which it is combining, and the second is it will also depend upon the reaction conditions. कौन से रिएक्शन कंडीशन में ये रिएक्शन होगा. ओके, उसके हिसाब से अलग अलग ऑक्सीडेशन स्टेट वो दिखा सकता है. तो ये मैंने आपको जनरल बताया. अभी हम बात करेंगे ऑक्सीजन के बारे में. सो व्हेन यू टॉक अबाउट ऑक्सीजन, oxygen charges are the very first, the most common, oxides. Okay, oxygen forms oxides, और oxides में उसका चार्ज है -2. ओके, फिर बनाता है वो पेरोक्साइड्स, तो उसके लिए उसका चार्ज है -1. एग्जाम्पल देता हूं मैं आपको, H2O2. ओके, दिस इज हाइड्रोजन पेरोक्साइड एंड एवरी ऑक्सीजन शोज अ चार्ज ऑफ -1. ओके, apart from this, it also combines with fluorine. Now, what is the speciality, what is the uniqueness about fluorine is, fluorine, you know, is the only element in the entire periodic table which has electronegativity greater than oxygen. So it forms 2 types of compounds over here. It forms OF2 as well as O2F2. Fluorine always shows a charge of -1. So when it shows a charge of -1, so -1 and -1 gives you -2. So if to balance this charge, then oxygen has to have a charge of what? +2. यहाँ पर O2F2 है. ओके, तो यहाँ पर भी वैसा ही है, -2 आएगा. लेकिन यहाँ पर 2 ऑक्सीजन है, तो +2 डिवाइड बाई 2, सो ऑक्सीजन का चार्ज कितना हो जाएगा? +1. सो इसका मतलब ये है दोस्तों, what does it mean? That when oxygen combines with fluorine, it shows a positive charge. Otherwise, it will show a negative charge. Okay, and I gave you the reason that why with fluorine it shows a positive charge, and that is because that fluorine is the only element which is more electronegative than oxygen. All right, and that's why oxygen shows a positive charge. Okay, next thing is, we talk about the next element. Now the next elements in this group 16 are what? Sulfur, selenium, tellurium and polonium. Okay, these are the elements. So what is the speciality of these elements? इन elements में कौन सा ऑर्बिटल है जो ऑक्सीजन के पास नहीं है? और आंसर तुरंत आपके सामने आ जाना चाहिए. मैंने लास्ट लेक्चर में आपको एनोमलस बिहेवियर में बताया था ये, एंड दैट इज व्हाट? डी ऑर्बिटल्स. Oxygen does not have a d orbital, whereas sulfur, selenium, tellurium, those have d orbitals. Now, because of these d orbitals, okay, because of these d orbitals, what are the changes going to take place? What is the effect going to take place on the oxidation state that we are going to discuss? Okay, so before that, if you can take the screenshot of this, you can take it, and then I'll explain you the significance of the d orbital on the oxidation state. You can take the screenshot of this. Okay, I hope you must have taken the screenshot of this. Now we can move ahead. And that is, we talk about the relevance of the d orbitals. So I give an example of sulfur. Sulfur का atomic number है 16, तो उसका electronic configuration is 3s2, 3p4 and 3d0. Okay, last lecture I already told you about what is the relationship between the vacant orbital and the absent orbitals. Okay, in oxygen, the d orbitals are absent, but in case of sulfur, the d orbitals are present, but they are vacant. Okay, so now what we can do is, I'll show the arrangement now of sulfur, 3s, 3p and 3d. S has only one orbital, P has got 3 suborbitals, and D has got 5 suborbitals. You know this. Okay, these are basics. Okay, sulfur in the ground state. Okay, now sulfur in the ground state is 3s2, 3p4 hai. So 1, 2, 3, and then this is 4. Okay, so this is the arrangement. So you can see this, the 3d orbitals are present, but they are what? Vacant. Now this is ground state. ग्राउंड स्टेट का मतलब जानते हो ना, द लोएस्ट ऑक्सीडेशन स्टेट. ओके, जहां पर एनर्जी लेवल इज मिनिमम. लेकिन अगर हमने एनर्जी दिया तो इलेक्ट्रॉन्स गेट्स प्रमोटेड टू द नेक्स्ट वेकेंट ऑर्बिट. तो इलेक्ट्रॉन प्रमोशन के लिए वेकेंट ऑर्बिटर होना जरूरी है, और सल्फर के पास वो पॉसिबल है बिकॉज द डी ऑर्बिटल इज वेकेंट. Okay, so as a result of which, what happens is that this electron, this part, okay, will go into the 3D state. So I get sulfur in the excited state 1. Now I'm giving numbering to the excited states. Okay, I'm giving what? Numbering to the excited state. Why? Because it can be more than one excited state. कैसे पता चलता है कितना एक्साइटेड स्टेट है? ओके, सिंपल मैं बताना चाहूंगा, एंड दैट इज द नंबर ऑफ पेयर्ड इलेक्ट्रॉन्स और नंबर ऑफ पेयर्स ऑफ इलेक्ट्रॉन्स इन द ग्राउंड स्टेट, दैट इज इक्वल टू द नंबर ऑफ एक्साइटेड स्टेट. तो ग्राउंड स्टेट में आप देखो, देयर आर टू पेयर्स, वन इन 3s एंड द वन इन 3p. सो देयरफॉर देयर विल बी टू एक्साइटेड स्टेट, because in the excited state the electron which are paired, they are being unpaired and they are promoted to the next vacant orbital. Okay, that is what is the principle behind excited state. So have a look over here. Ye pair remains the same. This electron gets transferred over here. So you get this way. Okay, this is what you get. Now what happens is 1, 2, 3 and 4. These 4 be involved in bonding, and therefore the charge they will show will be +4 charge. Okay, so high one is S, the three are P, so it is sp3, and this is one single orbital, that is d orbital. So sp3d hybridization होता है और उसका oxidation state कितना होगा +4. Now sulfur in the excited state to one electron, this will be transferred to the next d orbital. तो इसके हिसाब से we have this single electrons and like this. Okay, ये अभी इधर चला गया, तो अभी hybridization क्या होगा, sp3d2, and total there are 6 electrons which are single, so all the 6 can be involved in bonding purpose, and therefore the charge will become what, +6. So यहाँ पर अगर आप देखो, in this case, okay, only 2 of them are involved, so it is +2. okay, यहाँ पे +4 और यहाँ पर +6. यहाँ पर जो hybridization है, this hybridization is sp3. It is not involving d orbital, +2 is the oxidation state. यहाँ पर एक d orbital involve कर रहा है +4, यहाँ पे दो d orbital कर रहा है involve, तो it is +6. Okay, so this is what happens when you talk about with respect to sulfur, selenium, tellurium. Polonium हम लोग इग्नोर करने वाले क्योंकि मैंने आपको पहले ही बता दिया, and that is it is radioactive. Okay, यानी this is what the oxidation states are all about. Now if I ask you one question, and please you can give me the answer also, okay, by comments you can give me the answer over here as well, and that is, okay, suppose if I don't consider d orbitals, okay, I don't consider d orbitals, I consider only s and the p orbital, okay, सिर्फ s और p ऑर्बिटल में कंसिडर करता हूं, d ऑर्बिटल को मैं कंसिडर नहीं करता हूं. ओके, तो बताइए +4 and +6 oxidation state possible hota? Once again, go through this entire diagram and listen to my question and give me the answers. Okay, and that is, okay, if d orbitals are not present, all right, then +4 and +6 oxidation states, are they possible without d orbitals? बिना d ऑर्बिटल का +4 और +6 ऑक्सीडेशन स्टेट पॉसिबल होता इस एलिमेंट में, बताइए. Tell me, has everybody understood the question? Then please give me the answer. Okay, so your answer is perfect. So that means d orbital नहीं है. Okay, so it is not possible. Okay, क्योंकि d, देखो +4 के लिए भी d ऑर्बिटल है, देखो. ओके, ये d ऑर्बिटल कंसीडर किया हम लोग ने, +6 के लिए भी हम लोग ने d ऑर्बिटल कंसीडर किया. हाँ, +2 के लिए हम लोग ने d ऑर्बिटल कंसीडर नहीं किया है. तो हायर ऑक्सीडेशन स्टेट, मतलब +4 एंड +6 स्टेट के लिए d ऑर्बिटल का होना जरूरी है, और वही d ऑर्बिटल ऑक्सीजन के पास नहीं है. Oxygen does not have that d orbital. Okay, and therefore oxygen cannot show higher oxidation state. Okay, so यहाँ पे मैं लिख देता हूं, in case of oxygen, d orbitals are absent. Okay, vacant नहीं है दोस्तों, they are absent, and therefore cannot show higher oxidation state, और वो भी मैं ब्रैकेट में लिख देता हूं, +4 and +6 cannot show higher oxidation state of +4 and +6. बोलो, इतना समझा आप लोगों को? Have you understood this last line what I written? Once again I repeat that last line. In case of oxygen, d orbitals are absent and therefore cannot show higher oxidation state of +4 and +6. Come on, has everybody understood this? Okay, fine. So you can take the screenshot of this. Okay. Now after considering this group 16, we go into group number is 17. The very first, first of all is the VACC, I'll write it down, valential electronic configuration, and that is going to be NH2 and NP5. Okay, it is NH2 and NP5. So the oxidation state that they have is -1. They got 7 electrons in the outermost shell. So they are going to gain 1 electron to complete the octet. All right. So its charge will be what? -1. Okay, this is what the general is. Now we start with fluorine. When we talk about fluorine, see my difference, I'm writing in bold letters. Fluorine always shows an oxidation state of -1. Always. Okay, in bold letters. Okay, why is it so? The reasons are, first reason, atomic size is smallest. Second reason is electronegativity is highest. And also one more important point is in the entire periodic table. Yeah, atomic size smallest है वो only in group 17. लेकिन ये जो इलेक्ट्रोनेगेटिविटी हाईएस्ट है दैट इज इन द एंटायर पीरियोडिक टेबल. और तीसरा है एब्सेंस ऑफ डी ऑर्बिटल्स. ओके, एब्सेंस ऑफ डी ऑर्बिटल्स, क्योंकि यहां पर एन का वैल्यू सेल्फ फ्लोरीन के लिए 2 हो जाएगा. For fluorine, the n value is what? 2. And you know very well, the d orbital starts from the third shell. Okay, it doesn't start from the second shell. So ये 3 reasons है. Atomic size is small amongst the group 17 elements. Next is electronegativity is highest in the entire periodic table and absence of d orbitals. ये 3 reason के वजह से fluorine will always show an oxidation state of -1. All right, so this you need to remember. Next one is the other ones, the other halogens, that is chlorine, bromine, and iodine. So chlorine, bromine, and iodine can show positive oxidation state when they combine with oxygen. ओके, फ्लोरीन जब ऑक्सीजन के साथ कंबाइन होता, अभी थोड़ी देर पहले मैंने बताया था, तो फ्लोरीन का चार्ज पॉजिटिव नहीं होता, ऑक्सीजन का चार्ज पॉजिटिव हो जाता है, क्योंकि फ्लोरीन इज मोर इलेक्ट्रोनेगेटिव. लेकिन व्हेन यू टॉक अबाउट क्लोरीन, ब्रोमीन एंड आयोडीन, in this case the chlorine, bromine and iodine are less electronegative than oxygen, and therefore when they combine with oxygen in different proportions, it shows positive oxidation state. Also, there are one category of compounds. We will be discussing this in the later part of the chapter, and those category of compounds are called as interhalogens. Okay, what are they called as? Interhalogens. Okay, they are considered as interhalogens, and in this interhalogens they have a positive oxidation state. Now, what are those interhalogens that I'll explain you, okay, when that particular portion is being conducted. But if you want to consider what are the positive oxidation states, I will tell you that, and that is +1, +3, +5, and +7. Okay, these are the various positive oxidation state the halogen can show when they are forming interhalogens. Okay, so once again I repeat, इफ यू हैव मिस्ड आउट एनीथिंग तो मैं आपको वापस रिपीट करके बताता हूँ. हम फिलहाल कंसिडर कर रहे हैं ग्रुप 17 एलिमेंट्स. तो उसका जो VACC है, वैलेंशियल इलेक्ट्रॉनिक कॉन्फ़िगरेशन, एंड दैट इज नथिंग बट इट इज NH2 तो इसके हिसाब से द वैलेंशियल कॉन्फ़िगरेशन के हिसाब से द ऑक्सीडेशन स्टेट बिकम्स -1 because it will gain 1 electron. Next point is fluorine always shows -1. हमेशा -1 चार्ज दिखाएगा. उसकी रीजंस मैंने बताया था. एटॉमिक साइज इज स्मॉलेस्ट इन द पर्टिकुलर ग्रुप 17, electronegativity highest in the entire periodic table, and then we talk about the absence of d orbitals. अब दूसरे जो एलिमेंट्स है क्लोरीन, ब्रोमीन एंड आयोडीन, they can combine with oxygen and they can show a positive charge. Also, they combine amongst themselves, okay, forming interhalogen compounds, and they show positive oxidation states, and those positive oxidation states are +1, +3, +5, and +7. All right. So I hope you have understood up to this very well. You can please take the screenshot of this. First of all, before taking the screenshot, please tell me, okay, in the comment box, have you understood or not? Please type either Y or N so that I will understand this, whether you are getting cleared or not. Please tell me, have you understood? Okay. Now take the screenshot of this. Okay, fine. We will continue now. After group 17, we will go into group 18. When you go in group 18 now, those are inert gases. Now, why do we call it as that? Because the valence shell electronic configuration is NH2 So it has got a completed octet. So therefore it is stable. And therefore it has neither a tendency to lose electron or gain electron. And the physical state is gases. And that's why we say it is inert gases. Okay. Now, the next important point is, now because they do not have any tendency to gain or lose electron, and therefore they do not exhibit any oxidation state. But then when you talk about xenon, it does forms compounds. Xenon does form compounds. Now why? The reason, our first one is, it has got a larger size as compared to helium, neon, argon, krypton. Xenon के बाद आता है नेक्स्ट एलिमेंट रेडॉन, लेकिन वो रेडियोएक्टिव है, इसलिए हम उसके बारे में ज्यादा चर्चा नहीं करते. सो विल टॉक ओनली अबाउट xenon. Okay, it has got a larger size. It has got a lower ionization potential या ionization enthalpy. अब दोस्तों लार्जर और लोअर की जब मैं बात करता हूं, आई एम यूजिंग अ कंपैरेटिव वर्ड. प्लीज बी वेरी क्लियर. Okay, when I compare its ionization enthalpy with other elements, obviously this it's very high because it doesn't have any tendency to lose electrons. But then when I compare the ionization enthalpy of xenon with helium, neon, argon, krypton of the same group, then I say that it has got a lower ionization enthalpy. Okay, next is it also has vacant d orbitals. It has got vacant d orbitals. So because of these reasons, they do have a tendency to form compounds. Okay, because of these reasons. Which are those reasons? पहला reason क्या है कि size is large, दूसरा ionization enthalpy is less, और तीसरा because of the vacant d orbitals. तो उसके वजह से they do form compounds. लेकिन ज्यादा करके देखा गया है, now this is very important, they do form compounds all right, but with highly electronegative elements. They cannot combine with any elements of the periodic table. No. Okay? They will form compounds with highly electronegative elements. Okay, and that is nothing but oxygen as well as fluorine. तो मैं आपको कुछ एग्जांपल दे देता हूँ. XeF2, XeF4, XeF6, XeO3. ओके, तो ये फ्लोराइड्स है, ये ऑक्साइड्स है. ऑक्सीफ्लोराइड्स भी बनता है XeOF4, XeOF2. ओके, these are the compounds which are being formed. Okay, तो आप देख सकते हैं everywhere xenon is combining with fluorine as well as oxygen, which are highly electronegative. Fluorine is number 1 in the periodic table and oxygen is in the number 2 in the periodic table. Alright, तो ये कुछ compounds हम xenon के देख सकते हैं. These are the chemical compounds. Okay, so this is what we need to say about group 18. Okay, with respect to the oxidation state, that is their electronic configuration is NH2NP6. So generally they do not have a tendency either to gain electron or lose electron. All right, and therefore they do not show oxidation state. But xenon shows, and the 3 reasons I gave you and examples. And these are the 1 examples. Okay, so tell me now, have you all understood this? Anybody else got any doubts? Please tell me. Anyone? Any difficulty? Please, you can give me the comments of yours. Have you all understood? Okay, so you can take the screenshot of this. Which 3 and 4 points you're talking about, Nikita Pandey? This point, lower ionization enthalpy and vacant d orbitals. Last one. Okay, compounds which are highly electronegative के elements के साथ ये combine होगा. I'm giving you example reasons why xenon forms compounds. Okay, एक तो है xenon का size सबसे ज्यादा है as compared to helium, neon, argon, krypton, etc. etc. Okay, तो ये उसका size सबसे ज्यादा है. उसके बाद ionization enthalpy is low. Once again comparison किसके साथ है? वही elements के साथ है. Okay, of group 18. ठीक है, और तीसरा है it has got vacant d orbitals. तो ये 3 रीजन के वजह से they can form compounds. The other elements cannot. H compounds बोला जाता है उसको, तो वो एक नया अलग concept है. Let us not go into that. So I'm talking about chemical compounds. तो chemical compounds में ये reason के वजह से the xenon is going to form compounds. लेकिन उसके लिए condition क्या है कि it will combine with highly electronegative elements. Then only it is possible for the combination. Otherwise, the elements with less electronegativity, it will not combine. ओके तो कौन से हैं हाईली इलेक्ट्रोनेगेटिव एलिमेंट्स, नंबर 1 एंड नंबर 2 ऑफ द पीरियोडिक टेबल, एंड दैट इज ऑक्सीजन एंड फ्लोरीन. तो उनके साथ कंबाइन होंगे, okay, and forms various compounds depending upon the conditions in which the reaction takes place. क्योंकि मैंने आज ही के लेक्चर में आपको बोला था कि the oxidation state depends upon the nature of the element with which it combines and also the condition in which the reaction takes place. ओके इसके ऊपर आधारित है ऑक्सीडेशन स्टेट. तो ये xenon और फ्लोरीन, सब जगह xenon और फ्लोरीन कंबाइन हो रहा है, लेकिन कंडीशंस चेंज हो रहा है. द प्रपोर्शन इज चेंजिंग ऑफ xenon एंड फ्लोरीन, द टेम्परेचर इज चेंजिंग, द प्रेशर इज चेंजिंग, एंड देयरफॉर द कंपाउंड्स आर डाइफ्लोराइड, टेट्राफ्लोराइड, हेक्साफ्लोराइड. ऐसा यहाँ पर वो ऑक्सीजन के साथ कंबाइन हो रहा है तो इट इज गोइंग टू गिव ट्राइऑक्साइड. इधर वो ऑक्सीजन और फ्लोरीन दोनों के साथ कंबाइन हो रहा है तो दोस आर कॉल्ड एज ऑक्सीफ्लोराइड्स. बोलो समझा निकिता? Any others have any doubts? Please, you can tell me. Have you understood? The oxidation state shown by xenon, that is what the question is. So if fluorine always shows a charge of -1, so यहाँ पर xenon का charge होगा +2, यहाँ पर xenon का charge होगा +4, यहाँ पर xenon का charge होगा +6. ये ऑक्साइड के फॉर्म में है. I told you today's lecture only कि in oxide it has a charge of -2, so -2 into 3 is -6, तो xenon का charge will be +6. अभी इधर आओ. Okay, oxygen is -2, fluorine -1 each. So it will be -4. So -2 and -4 is -6. तो xenon का charge will be +6. यहाँ पर fluorine -1 तो -2. Oxygen का charge -2 तो -2 and -2 is -4. तो xenon का charge will be +4. So these are the oxidation states. So यहाँ पे +2, यहाँ पे +4, यहाँ पे +6. So +6, +4. Have you understood? Come on, please reply. Have you all understood? Okay, so you can take the screenshot of this. Okay. Now, my dear friends, we move on with the reaction with hydrogen. The second property is reaction with hydrogen. Okay, now group 16 and group 17 elements combines with hydrogen and it gives you hydrides. So we start with group number is 16. As I said, its electronic configuration is NH2 and NP4. So it requires 2 electrons to complete the octet. And because it requires 2 electrons to complete the octet, from where it will get 2 electrons? From hydrogen. Every hydrogen has got 1 electron, you know that very well. So 2 hydrogen will give 2 electrons. And therefore, group 16 elements will combine with 2 hydrogen. Okay, forming hydrides. So group 16 elements combines with 2 hydrogen giving hydrides. and the formula of those hydrides will be H2E. Now where E is nothing but group 16 element. तो ये formula हो जाएगा. Group 16 element will combine with the two hydrogen forming hydrides having the formula H2E. तो अगर पहला एलिमेंट कंसीडर किया जाए तो दैट इज ऑक्सीजन. सो यू कम टू नो द मोस्ट कॉमन कंपाउंड एंड दैट इज H2O. ओके, तो उस हिसाब से वी गेट वेरियस कंपाउंड्स. सो वी हैव H2O, देन वी गॉट H2S, वी हैव H2Ac, वी हैव H2Te, एंड देन वी हैव फाइनली H2PO. ओके, ये अलग अलग कंपाउंड्स हमें मिलेंगे. ओके, नेक्स्ट थिंग इज के they will be having two lone pair of electrons. ये मैंने आपको बताया था, excited state 1 and excited state 2 in this lecture itself. All right, so oxygen, it has got two lone pairs. Sulfur also has got two lone pairs. Tellurium also has two lone pairs, and polonium also has two lone pairs, because the electronic configuration for all these elements is same. Okay, लेकिन क्या हो जाता है कि in case of oxygen, though the number of lone pairs are 2, but electronegativity is more. So electronegativity and lone pair results in greater repulsions. Okay, in case of oxygen, वापस बोलता हूं, सुनो अच्छी तरीके से. In case of oxygen, because there are going to be two lone pair of electrons, and plus oxygen is most electronegative in group 16, and therefore the repulsions are maximum. अब आप जानते हो अच्छी तरीके से repulsions are maximum, so that means they will try to go away from each other. Okay, and when they go away from each other, obviously the bond angle which is there, that is going to increase. और इसलिए amongst all the hydrides, H2O has the highest bond angle. उसका वैल्यू भी शायद आप जानते होंगे. You have done this in your lower classes, and that is 104.3. It is. I just consider it 104 degrees. Okay, and then we have 92 degrees, 91 degree, 90 degree. This is, of course, polonium is radioactive, so we are not going to consider this. तो देखो, जैसे जैसे इलेक्ट्रोनेगेटिविटी कम होते जा रहा है, वैसे वैसे बॉन्ड एंगल कम होते जा रहा है. क्योंकि इलेक्ट्रोनेगेटिविटी कम हो गया, repulsions becomes less. Repulsion becomes less, that means the species will try to come closer. और अगर वो नजदीक आएंगे तो ऑब्वियसली बॉन्ड एंगल कम हो जाएगा. जब दूर जाएंगे तो बॉन्ड एंगल बढ़ता है, जब नजदीक आएंगे तो बॉन्ड एंगल कम हो जाता है. ओके, सो दिस इज व्हाट यू नीड टू रिमेंबर. नेक्स्ट थिंग इज आई विल टेल यू अबाउट हाइड्रोजन बॉन्डिंग. Hydrogen bonding is nothing but it's a bond between hydrogen and a more electronegative element. Okay, so when you know about H bonding, okay, it's not a bond between hydrogen and hydrogen. No, it's a bond between hydrogen and a more electronegative element. उसके बीच में होता है. So इसका मतलब यह हो गया कि the strength of hydrogen bonding is directly proportional to the electronegativity of the element with which it is combining. वापस से बोलता हूं, सुन लीजिए अच्छी तरीके से. If you have missed out anything, what is hydrogen bonding in simple words? And that is, it is a bond between a hydrogen and a more electronegative element. Examples I can give you is like nitrogen, oxygen, okay, sulfur, fluorine. Okay, these are the elements which are going to be more electronegative. तो हाइड्रोजन जब एक इलेक्ट्रोनेगेटिव एलिमेंट के साथ बॉन्ड बनाता है, आइदर ऑफ द सेम मॉलिक्यूल और डिफरेंट मॉलिक्यूल, तो उस बॉन्ड को हम लोग बोलेंगे हाइड्रोजन बॉन्डिंग. देन इट कैन बी इंटरन्यूक्लियर, ओके, या इंट्रा, ओके, इंटरमॉलिक्यूलर और इंट्रामॉलिक्यूलर, डिपेंड्स अपॉन कि इफ द सेम मॉलिक्यूल इज है तो इंट्रा, अगर डिफरेंट मॉलिक्यूल्स है तो दैट इज इंटर. Alright, so this is hydrogen bonding. तो अगर मुझे फाइंड आउट करना है कि हाइड्रोजन बॉन्डिंग का स्ट्रेंथ कहां पर ज्यादा है, where it is going to be more, so it is directly dependent on what. हाइड्रोजन तो कॉमन है, कौन अलग है, द इलेक्ट्रोनेगेटिव एलिमेंट, तो उसके ऊपर वो आधारित है. जितना ज्यादा इलेक्ट्रोनेगेटिविटी होगा उस एलिमेंट का, उतना हाइड्रोजन बॉन्डिंग विल बी स्ट्रॉन्ग. और इसलिए मैं आपको बताना चाहता हूं HF में हाइड्रोजन बॉन्डिंग इज स्ट्रॉन्गेस्ट, क्योंकि फ्लोरीन से ज्यादा इलेक्ट्रोनेगेटिव एलिमेंट कोई नहीं है. Am I clear with this part? लेकिन of course I won't be considering fluorine in this particular section because I am discussing right now group 16. It's an oxygen family. So in group 16, oxygen is mostly electronegative. और इसलिए हम लोग क्या बोलेंगे, वाटर में जो हाइड्रोजन बॉन्डिंग है दैट इज स्ट्रॉन्गेस्ट, और इस वजह से ये स्ट्रॉन्ग बॉन्ड को तोड़ने के लिए ज्यादा एनर्जी चाहिए. And because of which there are other properties also which I'll tell you. So hydrogen bonding is going to be highly strong in case of what? H2O, and therefore it has got a higher boiling point, and therefore it is a liquid. वो क्या है? Liquid है. Whereas ये जो है, let us ignore this because this is radioactive. ये लेकिन H2S, H2SE और H2TE जो है, those are gases. क्योंकि वहां पर the force of attractions are what? Less. Okay, so therefore they are what? Gases. Okay, whereas in H2O they are what? Stronger forces of attraction, the hydrogen bonding I'm talking about, and therefore H2O is a liquid. उसका जो boiling point है that is going to be very high, okay, as compared to the others. Well, are you understanding this part? Everybody clear up to this? हाइड्रोजन बॉन्डिंग का कंसेप्ट क्लियर हुआ? Okay, now we go into the next point, that is thermal stability. TS लिखता हूं मैं short. Okay, that is thermal stability. Now, thermal stability, as the name suggests, it is an ability of the species to sustain heat. That is called as thermal stability. एक स्पीशीज कितना हीट बर्दाश्त कर सकता है उसे हम लोग थर्मल स्टेबिलिटी बोलते हैं. So the species which can sustain a large amount of heat, then it is being called as what? Highly thermally stable. The one which can sustain less amount of heat, and if I supply small amount of heat and immediately the species, the bond breaks, so I say its thermal stability is less. If I supply large amount of energy and then the bond breaks, then I say the thermal stability is high. So मतलब ये होता है, thermal stability can be related to the strength of the bond. बराबर है ना? Thermal stability can be related to what? The strength of the bond. Greater the strength of the bond, greater is the thermal stability. और अभी मैंने आपको बताया, hydrogen bonding is very strong in water, and therefore the thermal stability will be very high in case of water. Okay, so therefore we will write it down, the thermal stability order, and that is H2O greater than H2S greater than H2SE greater than H2T. ऐसे हम लोग बोल सकते हैं. Okay, यानी वाटर में थर्मल स्टेबिलिटी इज हाईएस्ट and hydrogen telluride में the thermal stability will be lowest. Okay, that is what you have to understand. ठीक है? Next thing is in H2TE thermal stability is less. क्यों? Because the bonding is weak. अगर bonding weak है दोस्तों, तो hydrogen can be easily broken and being given away. Loss of hydrogen can take place easily. In H2TE हाइड्रोजन टेलुराइड में बॉन्डिंग वीक है, तो हाइड्रोजन जल्दी से लूज कर सकता है, एंड दैट लॉस ऑफ H is nothing but acidic character. The loss of H is a acidic character. और जो जल्दी से H लूज करेगा, that is highly acidic, because that H will be lost in the form of H plus. Okay, so therefore we say H2TE का acidic character will be very high, H2O का एसिडिक कैरेक्टर विल बी वेरी लो. ओके, तो अगर एसिडिक कैरेक्टर के बारे में जाना है, ये थर्मल स्टेबिलिटी का ऑर्डर है, तो एसिडिक कैरेक्टर का ऑर्डर विल बी ऑपोजिट, यानी इट विल बी लाइक दिस. H2T will be highly acidic and H2O will be least acidic. So these are the order of thermal stability and acidic character. Next thing is, जब हम loss of hydrogen की बात करते हैं दोस्तों, it is nothing but oxidation. You learn this in your lower classes. Gain of oxygen or loss of hydrogen is nothing but it is a property of what? Oxidation. So H2T can lose hydrogen very fast and therefore it undergoes oxidation very fast. और अगर उसका खुद का ऑक्सीडेशन जल्दी हो रहा है तो जाहिर सी बात है दूसरे का रिडक्शन जल्दी होगा. And therefore it is going to behave as a strong reducing agent. Agent means remember it is always for others. तो दूसरे सब्सटेंस के साथ जो होता है that word has to be written before the agent. और दूसरे सब के साथ क्या होता है, ओके, वो डिपेंड करता है खुद के साथ क्या हो रहा है. अगर खुद के साथ ऑक्सीडेशन है तो दूसरे के साथ रिडक्शन, अगर खुद के साथ रिडक्शन तो दूसरे के साथ ऑक्सीडेशन. तो इन H2T व्हाट वी हैव टू से इज कि उसका खुद का ऑक्सीडेशन जल्दी हो रहा है तो दूसरे का रिडक्शन जल्दी होगा, और क्योंकि दूसरे का रिडक्शन जल्दी होगा एंड देयरफॉर इट इज अ स्ट्रॉन्ग रिड्यूसिंग एजेंट. यानी हम इस तरीके से दो चीजें बात कर सकते हैं. एसिडिक कैरेक्टर इज डायरेक्टली रिलेटेड टू रिड्यूसिंग एजेंट, यानी जो ऑर्डर मैंने एसिडिक कैरेक्टर के लिए बताया था वही ऑर्डर मुझे बताने का है फॉर रिड्यूसिंग एजेंट एज वेल. एंड रिड्यूसिंग एजेंट लिख रहा हूं, इनके एसिडिक कैरेक्टर इज ऑल्सो लॉस ऑफ हाइड्रोजन एंड रिड्यूसिंग एजेंट ऑल्सो इज लॉस ऑफ हाइड्रोजन. अगर किसी भी सब्सटेंस को रिड्यूसिंग एजेंट की तरह बिहेव करना है तो इट हैज टू हैव एन एबिलिटी टू लूज हाइड्रोजन, यानी उसका खुद का ऑक्सीडेशन होना जरूरी है. So the order will remain the same. यानी मैं आपको वापस से पूरा बताना चाहूंगा what exactly it is. We are talking about thermal stability. Thermal stability is related to the strength of the bond. कौन से बॉन्ड की बात कर रहा है? हाइड्रोजन बॉन्डिंग. हाइड्रोजन बॉन्डिंग का स्ट्रेंथ is directly proportional to electronegativity. As we go from oxygen to tellurium, polonium we are ignoring. So as we go from oxygen to tellurium, the electronegativity is decreasing, okay, steadily. So therefore the hydrogen bonding का strength also is decreasing, and therefore hydrogen bonding is strongest with water and then it goes on decreasing. क्योंकि बॉन्ड का स्ट्रेंथ कम होते जा रहा है तो ऑब्वियसली ओके उसमें ताकत नहीं रहेगी, थोड़ा सा वो एनर्जी देंगे तुरंत टूट जाएगा, तो थर्मल स्टेबिलिटी कम हो जाएगा. तो देखो ये थर्मल स्टेबिलिटी कम होते जा रहा है, जैसे जैसे हाइड्रोजन बॉन्डिंग कम होते गया वैसे वैसे थर्मल स्टेबिलिटी कम होते जाएगा. ओके, नेक्स्ट थिंग इज कि हाइड्रोजन टेलुराइड में बॉन्ड स्ट्रेंथ इज वीक, it will lose hydrogen very easily, that is acidic character, so it is highly acidic. So hydrogen telluride is highly acidic. Loss of hydrogen is a property whereby it behaves as a reducing agent. Loss of hydrogen is a oxidizing property, लेकिन वो खुद का ऑक्सीडाइजिंग हो रहा, खुद का ऑक्सीडेशन हो रहा. ओके, यानी दूसरे का क्या होगा? रिड्यूसिंग. यानी any species which is going to lose hydrogen very fast is going to behave as a very good reducing agent. तो इसलिए यहां पर देखो H2T is going to behave as a very good reducing agent. Okay, whereas H2O is going to behave as a weak reducing agent. Okay, H2O is acidic character is very less. आपको तो मालूम ही है pure water is neutral, ये अच्छी तरह से जानते हो आप. Okay, so its acidic character is very less. H2E का acidic character is very high. Amongst, याद रखिएगा, amongst हाइड्राइड्स ऑफ ग्रुप 16, पहले ही बोल देता हूं ये मैं कंपैरेटिव बात कर रहा हूं दोस्तों. ओके, ओनली एंड ओनली कंपैरिजन. बोलो दोस्तों, समझ में आया आप लोगों को? हैव यू ऑल अंडरस्टूड दिस? Yes, please, my dear friends, waiting for your comments. Have you all understood this? Okay, you can take the screenshot of this. All right, so I guess you must have taken the screenshot of this, and this is what we have discussed in this lecture. The chemical properties. The first chemical property was oxidation state. So that we discussed with respect to group 16, 17, as well as 18. All right, and then we discussed with the property of combination with hydrogen, giving what hydrides of group 16. I have explained you. So I guess the time is also up. It's 1 hour. Okay, and this was the first experience whereby we have taken a lecture. We are live right now. Okay, YouTube live streaming it is. Okay, and I enjoy presenting these topics in front of you, and I hope you have also enjoyed this lecture. Thank you so much for joining me, and I'll see you next time. So thank you so very much.